Okay, now let's have a look at differentiation. When you say differentiation, what does that mean? Differentiation is a method of calculating for the gradient of a curve, not a straight line. It's easy when it is a straight line. But what about if it is a curve? As we have y is equal to f of x. This curve, how do you find the gradient of it? So let's look at a method of calculating for gradient of a curve. So if you have a point here, x, then the corresponding y value will be f of x. Now, the distance here, up to this point, let the distance be delta x. It means x must be added to this distance to get the next point. So here, we shall have x plus delta x. And now, the corresponding y value will be f of x plus delta s. Now, one thing that is very significant is that we want to bring this point closer, very closer to this point, so that it will almost closer to the sense that when you are bringing this, you see that the delta x will be reducing. It will be coming to this side, to the sense that the distance between this point and this will almost be zero. The distance here, because if you pull this one closer, the point is brought here. When you bring the point here, you see that the straight line will look like this. And this part of delta x will be off because delta x is approaching this side. Then you will bring the point closer again to this side. You see the straight line will look like this. And delta x will be within this range. Now, I'll bring it closer again. See that delta, to the sense that when you bring it closer to this point, delta x to this point, you see that the 2 points are so close. If you draw a straight line on them, it will be flattened on the curve. So if you bring it to a center that is so close, delta x is almost becoming zero. It's approaching zero. It is then that you can approximate the gradient of the curve to that of the gradient of the straight line to that of the curve. Now let's pick the point, because we have first point x, and then the corresponding y value is f of x. Now that's A. B, because you need 2 points to find the gradient of a line. 2 points on that line. Now B, the x value will be x plus delta x, and the y value will be f of x plus delta x. Now, changing y over changing x, as you know, in calculation of the gradient of a straight line, is equal to dy, delta y will approach dy, delta x will approach the x. Will also be approximately, because we are approximating that of the curve, we are approximating the gradient of the straight line to that of the curve, because we are bringing this point so close to say that we shall get a straight line. The points will be almost closer to each other. So it's an approximation. It's equal to the first y1, which is f of x plus delta x, minus y2, f of x, divided by x1, which is x plus delta x, minus x2, which is x. X cancel this x, then you have dy dx is approximately equal to f of x plus delta x minus f of x, all divided by delta x. Limits as delta x approaches 0, because as delta x approaches 0, delta x, you know, delta x is reducing. It reduced to this side, this part is away. If to this side, as we move the point closer and very closer to this point, so to say that delta x is almost approaching 0, then we get the point which is closer, very closer to the first point, so that calculation of the gradient becomes easy. So this is an approximation. Dy dx should be written as approximately equal to this. And sometimes it's very difficult to work with delta x, so it is easy for students to work with h. So if delta x is equal to h, we shall have dy dx is equal to f of x plus h minus f of x all over h, limit as h approaches 0. And that is the formula for calculation of a gradient of a curve. Thank you very much for watching me.